So the year is 1976. You're a dude named Bill Joy. And Chuck Haley. So by hacking together an line editor named Ed, they form the Bobby M. What the Sigma? So they hack some more, and they create Vi. And just like malware, it was eventually all over the systems. And then Bill pulls out and cucked for Emacs instead. A few years later, in 1991, you're a pretty cool dude named Bram Molinar. Makes Vim, refuses to elaborate. Fucking dies. Rest in peace though, you were a hero, Bram. While the name might sound like it was forked from Vi, it was actually forked from a clone of Vi named Stevie. Because licenses are funny. There were actually a few other forms of Vi that have been lost through the sands of time. I wonder why. Vim extended Vi, or CVI, I guess, in many ways, fulfilling the lusts and desires of the fresh, cool new terminals craving visual displays in the sick 90s. It was, and still today with the right mindset, is a text editor perfect for productivity. Not sponsored. So, Vim held on. Presenting to the emergency room, where we are now. Let's say we are Jay Clancy, 2012, or one of the many brave souls before him who never reached escape queue. But instead of killing the process in another method of their choice, they just stayed.
Vim no longer needed its ultimate practitioner. It had become a self-sustaining system. Man was crushed under the code created to create the code to crush the code. Samsara of segfaults and compile errors, death without life, null Ouroboros. The dream without reason, magnum opus.
Where am I? Oh, what? I guess I'm stuck. But I mean, what would you want to leave them anyways? Look at all the things they offer. Now, Vim was also designed to not use a mouse, so... So, yeah, let's see what extent we can use for Vim. But instead of NVim, we're not fucking Zoomers. I'm an angry boomer. So as you saw, I launched the Vim binary and that's clean. So there's no plugins, no nothing. So the first thing I do when I wake up in the morning is usually to shitpost. So there are a few ways you can interact with the interwebs on Vim. You can basically, this is like standard in, so you can create a curl command right here at your fingertips. So if we write like this, because we need a Vim reference, right? And then we just do curl config standard in. Okay, we need to make this a file first, I guess. And here we have it. Now, a certain image board requires CAPTCHA nowadays. And, well, I am a robot. But here, I just took a post request to some crappy alternative. I could have done with Chen, because it would be a little bit funny to watch him thieve, but I will go with this one. Great, shit posting done. What else do people at a computer do? We could, for example, start programming something, because it works really well as an IDE once you learn buffers. However, programming, for me, little Kaliwali, stupid, no. But there's one more thing that's really cool and awesome, and the reason I kinda made this video. Because, like, VimScript is, well, VimScript, but Vim in normal mode is actually Turing complete. So to get everyone, or well, the one singular person watching this video, hi Dad, I love you, on the same page, I'll just super simplify what Turing complete is. So Mr. Turing was a smart little gay boy who made some amazing things, like the bomb. He got the funny little puzzle called the Einstein problem, which questioned if any math statement could be proved with a systematic method. By the way, it's not. And this problem is kind of what Turing completeness stemmed from. But okay, what is Turing completeness? So a program can be thought of as just a bunch of instructions made in a language of your choice. Usually these are languages like C, PHP, JavaScript, but as long as a language have conditional repetition, like a while or if, and a way to read and write storage, like variables, and basic operations like add, sub, and compare, it is most likely Turing complete. So basically, if a machine with this language gets a problem, even if it's the most complex problem ever, if you assume unlimited power, it would be able to solve it. Maybe to understand it a bit easier is to see stuff that is not Turing complete, like a basic calculator. It has a few features needed for Turing completeness, like add, sum, and compare, but it can't store variables usually. Now, it doesn't even have to be just ordinary programming languages that are Turing complete. Hell, even Magic the Gathering is Turing complete. Okay, context switch. Vim. We're still stuck in Vim. So this project right here is a really cool project that, well, simulates the Turing machine just using Vim. So here's the makefile, which just builds some Python that scripts up Turing states in Vim. So it's still using Vim macros/registers. So like any IT professional would, let's just run and see what happens. So this prints the end result of our problem, which is merging intervals in this case. And scrolling up, we can see something similar to what we will find in the Turing machine example. Okay, so that's great and all, but how is this Vim? So, well, yes, there is Python, so we don't have to manually write until our fingers bleed, which will be very anti-Vim. Let's look at the constants on the Vim machine. So mainly here in constants, we can see where, well, I guess kind of the magic happens. So we're making Vim Turing complete by utilizing things called macros and registers. Well, this would probably be a very long video if I went into the nitty-gritty details of why these things work. So I'm just going to kind of display the registers and macros and marks which make this thing work. And then I'll link some cool papers and videos in the description so you can see the more nerdy stuff. So to kind of show the coolness of macros, I made this list, but instead of numbers I want it to be stars, and I want to capitalize the text to make it more hype. So to get started, we're just pressing the Q sign, followed by whatever letter you want, so let's just say E for example. And now we're recording, well, our finger strokes basically. We'll start from here. We'll do a record on, I don't know, R. And now we're recording, well, anything we would do to move in Vim. So let's start with 0 to be at the first line, which we are right now. And then we'll do delete until the dot. Then we want to insert a star and, I don't know, space to look pretty. Then we go escape, and we want to make the rest uppercase, so we do a GU until the end with a $sign and a J to move to the other line so we can repeat this macro. Call this macro again, so now we can just be wherever. Then we do 9 at R. And now we have done it 9 more lines. Wholly automatic. Now this example is simple enough to not use registers, but registers are basically a way for macros to use kind of like variables. Registers basically store data of sorts. So for example, if you yank something, we can, so now I press YY, and if we just go paste it, this is pasted because it's stored in a register we yanked. So if we look back in the code here, we can see, well, the macros, they use yanking, and a lot of other Vim magic, which I will link the project in the description if you're more curious. But this is essentially the core part of it, and I think it's really cool, and Vim is really cool, and I discovered a lot of new cool Vim stuff while making this video. Yeah, Vim is awesome, and if you got stuck in Vim and couldn't exit, it wouldn't matter. You would be happy in the end. As an end note, I would like to showcase some really cool Vim Turing Complete projects I found. So of course, this GitHub project, which, well, we recently went through. And then we also have the Game of Life, which was found on LeReddit, which is also just insane, man. We also have a brainfuck interpreter. And brainfuck is a pretty good display of Turing completeness because it's so minimal. So yeah, here's just a brainfuck interpreter made in Vim registers and macros. This brainfuck interpreter was made by a legend named Hilo, which is really good at macros. And he has an explanation on his Twitter here, if you're interested in more. And I also recommend this post, which also explains the little image I made earlier. And on that note, I will end the video. I really appreciate you watching, and I hope you learned something new. and I hope to play with you on stream or with videos again soon. Thank you and goodbye.